there's actually only two different alternatives when we are solving a logarithmic equation as opposed to an exponential equation. There is, as we showed in the first video, you can exponentiate by using the same base. The other alternative is, of course, to rewrite the logarithmic statement into its equivalent exponential statement. So, exponentiation base 3, and then switch the input and output. Not gonna lie, that tends to be the preferred method because it tends to be very, very clean. Very clean. From there, calculator to evaluate this. And a quick subtraction of 1 gives us the solution. This tends to be the preferred method by most students, I think. Besides the fact that it's pretty clean and quick, the idea of that exponentiation of having to put a big 3 down here and make this into a tiny exponent, and a big 3 here, and that tends to, I don't know, it just doesn't sit as well with many people. We tend to be used to the idea of writing an inverse operation like this right underneath, or even in the case of an x squared, of just writing a radical over it. The idea of actually having to rewrite the whole statement with a big 3 down here and a big 3 there, that just kind of, it doesn't sit as well. It doesn't seem as natural and familiar, which I totally get. So this tends to be the preferred method for logarithms, or for logarithmic equations, but again, whichever one you use, they both work. Now, one thing we might address is, why are there only 2 alternatives for solving logarithmic equations when there were 3 for exponential? Well, the second alternative for exponential was based off the idea that if we're going to have to convert to base 10 or base e anyway, why not just start with those 2? Well, the reason we have to convert to them is because the calculator only understands common log or natural log. So if we're going to impose a logarithm on the equation, it has to be in a form the calculator can understand. In this case, we're not doing that. We're actually removing the logarithm and replacing it with an exponential statement. And exponential statements are easy. There's no limitation on them. We could have any base and any power we want, and the calculator will evaluate it just fine. So we don't need that second option because there's no need to rewrite it into a form the calculator understands. It will understand whatever form this comes out in, regardless of the base of the logarithm at the beginning of the problem. So 2 alternatives: exponentiation of each side, matching the base of the logarithm, or, usually preferable, translate it into its equivalent logarithmic, exponential form rather. That's all there is to it.